Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we'll be seeing about numbers from natural numbers all the way up to complex numbers. So let's start with the simpler one, that is natural numbers. Natural numbers, the definition for natural number is it starts from 1 and it goes like this all the way up to infinity. So for example, we will have any number that is 1, 2, 3 like that. We take 4, we take 64, something like that, 1000. All these numbers are natural numbers. So this is the definition for natural numbers. Now the next thing for natural numbers is whole numbers. The thing about whole numbers is it starts from 0 and ends till infinity. So this is the thing for whole numbers. So this is just natural numbers including 0. So that is the thing with whole numbers. And the thing, the letter to denote natural number is, it is like this. This is the symbol for natural number. You can put like this or just n. These two are the symbols to denote natural numbers. For whole numbers, it is just a W like this, or you can just put W like this. These are the symbols to represent whole numbers. Now let's get to the next number. Next to the whole numbers is the integers. The thing about integers is it is also a group of whole numbers plus some numbers. So minus infinity 2, minus 3, minus 2, minus 1, 0, 1, 2 goes to infinity. So this is the thing with integers. So this is just whole numbers plus negative numbers. The symbol to denote integers is Z. This is the symbol to denote integers. Somewhere you can see something like this. This means positive integers. Or you can say this as natural numbers, because positive integers are nothing but natural numbers. Somewhere you can see like this. This means only the negative numbers. So these two symbols you can see somewhere, but this is the symbol to denote integers as whole. So this is integers. So the next numbers we will see is, from integers we will go to rational numbers. So the thing about rational numbers is, an important thing is it should be denoted with this P by Q form, which means all the numbers that can be represented as a fraction. So this is a rule for rational numbers, since the name denotes rational, that is a fraction. All the integers, let's say we have integers like minus 3, 4, these are all integers. So these are also rational numbers, because these numbers can be denoted by minus 3 by 1, 4 by 1 and something like that. So all integers are rational numbers, including all the other numbers which can be denoted with this form. For example, let's say 5 by 6 is a rational number, minus 3 by 2 is a rational number, a 0 is a rational number, since we can write this as 0 by 1. So all these numbers are rational numbers. And the letter for denoting rational numbers is Q. You can put like this or just Q. So this is the thing for rational numbers. You can also see some symbols like this, which means positive rational numbers, and Q minus means negative rational numbers. So that's another thing about rational numbers. The important thing is it should be in the form P by Q. So that is the most important thing for representing a rational number. Now the next number is, now this is the first thing, we will not have rational numbers into this. So these are called irrational numbers. That is the opposite of rational numbers. That is the numbers which cannot be denoted by this form. These are called irrational numbers. Example, let's say we have pi. This is an irrational number. Although we might say this is equal to 22 by 7, but that's actually false because pi does not equal 22 by 7. It only approximately, pi approximately equal to 22 by 7. So here 22 by 7 is a rational number since it is a fraction, but pi is an irrational number since it cannot be denoted as fraction. So that is one thing about irrational numbers. The other examples you can see is root 2 is an irrational number because it cannot be represented as a p by q form. So this is an irrational number. Other examples also include roots. That is the roots that cannot be reduced. For example, if you say all the roots are an example, then root 4 we have. Root 4 equals 2, but this is a rational number since we can denote it as 2 by 1. But root 2 is an irrational number since it cannot be written as, you can say it is written as root 2 by 1. But the thing about this is the p and the q you get should be integers. So p by q form cannot be written with root terms, that is root any positive terms that cannot be reducible. So the p and q in rational numbers must be integers. That is another rule with that. So root 2 it cannot be written as root 2 by 1. It can be written as root 2 by 1, but this cannot be equal to p by q form since p and q must be integers. But root 2 is not an integer. So that's the thing with irrational numbers. And the letter to denote this is, you can sometimes denote with I, but mostly you will see this is the symbol for irrational numbers. What this means is all the real numbers, which we will see next, all the real numbers minus the rational numbers. So this is the symbol we will mostly use for denoting irrational numbers. Now the next numbers, as I said, will be real numbers. So real numbers. So the thing about real numbers is it is just two numbers combined. That is rational numbers and irrational numbers. So real numbers refers to both rational numbers and irrational numbers. For example, any rational number or irrational numbers comes under real numbers. For example, root 2 is a real number since it is a irrational number. 2 by 3, it is a rational number, so it comes under real numbers. So that is the thing with let's say root 4, it gives 2, which you can write as 2 by 1. This is a rational number, so this is also a real number. And the letter for denoting real number is just the first letter of this, that is R. This we will see in lot of cases when we are not dealing with complex numbers, which we will be seeing next. So real numbers are like, you will see this denotation a lot of times in maths, so that will be really helpful for you. So the next number we will see is, it is actually not complex number, but it is the definition of complex number, that is imaginary number. Earlier we saw real number. The opposite of real number gives imaginary number. That is, all the numbers we know, like 2, 4 by 3, all these numbers we know, we come across. But these numbers are little bit rarer in maths. So the letter is I. This is the only number in imaginary numbers. But we can create a lot of numbers with I, like 2i, this is an imaginary number. 3 plus I, this is an imaginary number. So all the numbers that contains I are called imaginary numbers, since it contains an imaginary number. And the letter to denote imaginary numbers is this, not like a letter to denote imaginary numbers, because the only number it contains is I. So mostly this, if you see this, then it is an imaginary number. So that's the thing. Now the last final number we will see is, that is in the title, that is complex numbers. Complex number is just a branch of two, that is real numbers and imaginary numbers. So all the numbers we have seen so far comes under complex numbers. Let's say we have example like root 3, it is a complex number. Root 3i, it is a complex number. I plus root 3, this is a complex number. Let's say 2 by I, it is a complex number. But when we are dealing like this, we should always take conjugate. So this we will have minus 2 by I square is minus 1. So here we have minus I square. So we get plus 1. So this is minus 2i. So this is also a complex number. So that's the thing about complex number. And the letter to denote complex number is C. Like this. So this is the letter for denoting complex numbers. So that's all for the numbers from natural numbers to complex numbers. That's it. Thank you.